Hi, my name is Jeff, and today we'll be going over the deep ocean currents lesson. The goal of today's lesson is to teach students about deep ocean currents by allowing them to visualize and understand how and why currents form. You should start off the lesson by asking students if they know the two types of ocean currents, which are surface currents and deep ocean currents. Surface currents are driven by the wind blowing over the ocean and the Earth's rotation, whereas deep ocean currents are driven by the density and the temperature of the water. You should tell students that in this lesson, they're going to investigate the behavior of dense salt water and the behavior of cold water in relation to the room temperature water. In this part, you're going to explain the concept of density to the students by using a demo. Tell the students that they can think of density as how much mass there is in a given fixed volume. Show the students the jar with the marbles in it, and tell them that the marbles represent water molecules. Pour the salt into the jar, and show the student that the salt packs around the marbles. Explain that adding the salt increases the density of the water because there is more mass per volume. In this part, we're going to investigate the behavior of dense salt water. Start off by going over some basic background information on ocean water and compare it to lakes and streams, which contain fresh water. You should ask students why they think ocean water has a high degree of salt, whereas the water from lakes and streams contains fresh water with a low degree of salt. You should then explain to students that the salt contained in ocean water actually originates from the erosion of the Earth's crust through mountains and other landmarks that then deposit that salt through streams, through rivers, which travel and ultimately deposit the salt at the ocean. Now we're going to do an experiment to actually investigate the behavior of salt water. You should split the students up into groups, and for each group you should pass out the following materials. Each group should have two 16-ounce cups to be filled with water, one container of salt, one spoon, one plastic container, and one vial of food coloring. The following experiment, to be done in groups of 2 to 3, will help students visualize the behavior of deep ocean currents. Open the container of salt and add 3 spoonfuls to the water. After adding the salt, you should add approximately 15 drops of the blue food coloring. Be sure to stir the water, food coloring, and salt so that the solution reaches an even, dark consistency. Pour the salt water to the left side and the fresh water to the right side at the same time. The height of the water should be just above the height of the topmost nail in the container. Next, you should prepare to remove the 2 plugs that are in the middle barrier of the container. It is important that both plugs be removed at the same time. Once they have been removed, you should observe that the salt water moves through the bottom hole and that the fresh water moves through the upper hole. Next, have one VSVS team member go to each group to sprinkle pepper on top of the water on both sides of the container. You should see that the pepper on the side that was originally fresh water does not move much, but the pepper on the side that was originally salt water is circulating around. Explain to the students that they have just created currents, similar to those naturally occurring in the ocean. The blue salt water is denser than the fresh water, so it acts like the colder, saltier water of the ocean, while the fresh water acts like the warmer, less salty water of the ocean. Deep ocean currents are formed when denser water sinks and flows beneath less dense water, which in turn flows on top of the denser water, as observed in this experiment. In the final experiment, we're going to investigate the movement of cold water in the ocean. You will need the following materials: 2 jars, each with a hole on the lid, a piece of plastic, a cup with ice, and food coloring, which is not shown. Place a few drops of food coloring in the container with the ice. Into each container, the empty one and the one containing the ice, you should pour room temperature water. It is essential that each container is filled to the brim with water. After pouring in the water initially, you should screw on the caps to each container, but add any additional water if necessary. Slide the plastic square and hold it firmly over the container that contains the clear room temperature water. Prepare to flip this container while holding onto the plastic square and make sure no water leaks. Slide the container and the plastic square directly over the container with the blue liquid and carefully remove the plastic square such that the two containers are touching each other lid to lid. Observe what happens. If this procedure is performed successfully, there should be no flow of liquid between either container because the bottom container holds the more dense cold water, whereas the top container holds the less dense room temperature water. Repeat this procedure except with the cold water container on top. Put the plastic over the cold water container, flip it carefully, and slowly align it with the bottom room temperature container and slide the plastic off. This time we do observe a flow of liquid from the top container to the bottom. This is because now the more dense cold water is on top and it sinks slowly into the bottom container, which houses the less dense room temperature water. The key concepts of this experiment are that the density of water fluctuates based on temperature, specifically colder water being more dense than warmer water. This density fluctuation has consequences in the atmospheric warming of water currents, causing warm water regions to rise above colder water regions. At this point, the students should have covered all of the key concepts and be able to synthesize everything learned in the final application-based activity of this lesson. For part 4 of the lesson, you should have students refer to the map of deep ocean currents. The biggest source of deep water occurs when highly saline surface water from the Gulf Stream is cooled by the polar air and then moves south, flowing all the way to Antarctica. The densest water forms in the Weddell Sea of Antarctica during the southern winter. This water sinks to the bottom of the ocean and then proceeds to flow north. When ocean water freezes into icebergs, the ice is made of pure water, while the salt left in the water in the ocean increases the salinity and density. Relate this phenomenon to the marble demonstration in part 2. That concludes the lesson, and you should discuss the 2 main review points with students before you leave. Ask students why salt water is more dense than fresh water. They should answer that salt water has a higher mass but the same volume of fresh water. Ask students, what can we say about cold water versus warm water? They should give an answer along the lines of cold water sinks and warm water rises. That concludes this VSVS training video. Please note that while the contents of this video are accurate, we encourage all students to visit the VSVS website and read the most updated version of the Deep Ocean Currents Manual.